Imagine a giant ball of ice floating in the vast emptiness of space, a frozen sphere so immense it dwarfs any comet or planet we've ever seen. Picture it drifting silently, untouched by the warmth of any nearby sun, its surface glistening with frost and ancient frozen gases. Now imagine this isn't just a planet or a moon, but a star made entirely of ice, colder than anything we know, with temperatures plunging near absolute zero. Its surface would be so frigid that even the faintest touch of heat would vanish instantly, leaving only a ghostly mist swirling in the vacuum. This idea completely defies everything we understand about stars. Normally, stars are blazing hot engines of nuclear fusion, burning with unimaginable energy and light. They are the cosmic furnaces that forge the elements and illuminate the universe. But this ice star would be the opposite. Instead of burning plasma, it would be made of frozen gases and solid particles, emitting almost no light at all. Its presence would be marked by a faint, eerie glow, if any, barely distinguishable from the darkness around it. The existence of such an object would challenge our most basic ideas about how stars form, live, and die. It would force astronomers to rethink the very foundations of cosmic structure, and question what truly defines a star in the first place. An ice star would still be a gravitational anchor, holding planets and debris in its sway. But instead of radiating heat and light, it would radiate cold and darkness, casting a shadow across its entire system, a silent, chilling presence at the heart of its own miniature universe. It's a true cosmic paradox, a star that absorbs rather than emits, a void where a beacon should be. It would be more like a black hole of cold, a place where energy disappears instead of being created. Exploring this idea pushes the limits of our scientific imagination. It invites us to consider the wildest possibilities, to ask questions that have never been asked before, and to dream beyond the boundaries of what we think is possible. What if a star's role wasn't about burning bright, but simply about being the center of a system by gravity alone? Could a star exist that never shines yet still shapes the orbits of worlds around it? Maybe it's time to redefine what we mean by star. Perhaps the universe holds secrets that don't fit our current definitions, waiting for us to discover and understand them. Could such an object really exist? And if so, what would it mean for our understanding of the cosmos? Would it change the way we look at the night sky, or even our place in the universe? This is the journey into the paradox of the ice star, a voyage into the unknown, where the rules of the universe are rewritten and where imagination becomes the key to discovery. To truly grasp just how strange and fascinating the idea of an ice star is, we first need to understand what makes a star in the first place. It's easy to take for granted the twinkling points of light scattered across the night sky, but their true nature is far more complex and awe-inspiring than it might seem at first glance. So let's take a step back and revisit the fundamental qualities that define a star, and why these cosmic objects are so unique in the universe. Stars are born deep within vast clouds of gas and dust called nebulae. Over millions of years, gravity pulls this material together, causing it to clump and compress. As the core becomes denser and hotter, a critical threshold is reached. Nuclear fusion ignites and a star is born. Fusion is the key process at the heart of every true star. It's a kind of cosmic alchemy where hydrogen atoms are fused into helium, unleashing an incredible amount of energy in the form of light and heat. This is what makes stars shine so brilliantly in the darkness of space. The energy from fusion pushes outward, creating a powerful force that balances the relentless inward pull of gravity. This delicate equilibrium is what allows a star to remain stable and luminous for billions of years. Our own sun is a perfect example of this balance. For over 4.5 billion years it has provided the warmth and light necessary for life on Earth, bathing our planet in energy and shaping the conditions for everything we know. But if a star loses its ability to fuse elements, it becomes something entirely different. Without fusion, there's no light, no warmth, and no solar wind. Just a cold, dark mass adrift in space. An ice star, by definition, would lack fusion entirely. It would be a star in name only, missing the very process that gives stars their energy and brilliance. Such an object would be unimaginably cold, dark, and silent, no outward energy, no radiant glow, just the crushing weight of gravity pressing inward. This raises a profound question: how could an ice star exist at all without simply collapsing under its own gravity? To resist collapse, it would need something extraordinary, perhaps exotic forms of matter, or an immense mass that creates new kinds of pressure to counteract gravity's pull. In this sense, an ice star is only called a star because it sits at the center of a system, acting as a gravitational anchor for orbiting bodies, not because it shines or radiates energy. It's a star in name, but in reality, it's a fundamentally different kind of object, one that challenges our very definition of what a star is. And that's the puzzle at the heart of the ice star paradox, a cosmic mystery that invites us to rethink everything we know about the stars above. If fusion doesn't power an ice star, what's it made of? In astronomy, ice means frozen volatiles, methane, ammonia, carbon dioxide, and water. Picture a sphere the size of a star made of these ices with a jagged, frozen surface. Instead of solar flares, you'd see cryogeysers, volcanoes of ice erupting into space. Its atmosphere would be a thin, frigid haze, with snow-like particles drifting down. To hold itself together, it might need a core of exotic matter, wrapped in layers of ice. This would make it a unique chemical time capsule, preserving the universe's primordial ingredients. Collisions wouldn't vaporize objects, they'd just add to the icy mass. Studying such a star would reveal the frozen history of its cosmic neighborhood. The most dramatic difference between a real star and an ice star is light. Light is not just a feature of stars, it's their very essence, the thing that makes them visible across the vastness of space. When we look up at the night sky, every twinkling point is a sun, radiating energy outward in all directions. Our sun is a blazing beacon. An ice star would be a sphere of darkness, visible only by the light it blocks or faintly reflects. Imagine a cosmic object that doesn't shine but instead swallows the light around it, creating a void in the sky where a star should be. It would appear as a black silhouette against the stars, a cosmic shadow. Unlike the familiar glow of a star, this object would be defined by its absence, a hole in the tapestry of the cosmos. Planets orbiting it would be nearly invisible, lost in the darkness. Without a source of light, their surfaces would be shrouded in perpetual night, making them almost impossible to detect from afar. Its surface might reflect a faint, cold glimmer if covered in fresh ice, but mostly, it would absorb light. Any shine would be fleeting, a pale echo of the brilliance we expect from stars. Unlike the sun, it would emit no solar wind, no radiation, no flares, just silence and cold. The space around it would be undisturbed, lacking the energetic outbursts that make stars so dynamic and alive. The space around it would be eerily calm, lacking the dynamic violence of a real star. There would be no auroras, no bursts of energy, only a chilling stillness that sets it apart from every other star in the sky. Detecting such an object would mean searching for darkness, not light. Astronomers would have to look for the places where starlight is missing, for the subtle clues that something massive is hiding in plain sight. It's the ultimate anti-star, a gravitational anchor defined by absence. Its presence would be felt only through its pull on nearby objects, not by any light it gives off. The contrast between light and darkness here is total. Where the sun brings warmth and illumination, the ice star brings only cold and shadow, a stark reminder of the universe's extremes. An ice star is the universe's way of showing us what happens when the rules are flipped. It challenges our very definition of what a star can be, existing as a paradox among the shining giants. It's a star that hides, not shines. A silent enigma, lurking in the cosmic dark, waiting to be discovered by those who dare to seek the invisible. Regular stars form through heat and collapse, but an ice star would need a cold, gentle birth. Instead of collapsing and igniting, it might form by slowly accumulating frozen material in the coldest regions of space. One idea, a brown dwarf, too small for fusion, gathers a thick mantle of ice over billions of years. Or, a primordial black hole acts as a seed, attracting layers of ice without ever heating up. The process would be slow and quiet, more like a pearl forming than a bomb exploding. No violent ignition, just layer upon layer of ice building up in the darkness. This gentle formation is key to preserving its icy nature. The result, a massive, cold object, stable and silent at the heart of its system. It's a star born not of fire, but of endless, patient accumulation. The ice star's origin is as strange as its existence. What would planets around an ice star be like? They'd orbit in perpetual darkness with no day or night, just eternal twilight. The sun would be a black void, offering no warmth. These worlds would be frozen solid, their surfaces locked in deep cold. Orbits would still exist, but seasons and temperature changes would not. Planets could be icy even close to the star, with no frost line to push ices outward. Tidal forces from the massive ice star could flex and crack planetary crusts, generating internal heat. This might create subsurface oceans, liquid water hidden beneath miles of ice. Life, if it exists, would depend on this internal warmth, not sunlight. The possibility of hidden oceans raises the question, could life thrive in the darkness? Around an ice star, the search for life would go deep below the surface. How would we ever find an ice star? They emit no light or heat, making them nearly invisible to traditional telescopes. Our best bet is gravitational microlensing, watching for the way their mass bends the light of background stars. If a star suddenly brightens and fades, it could be a massive, dark object passing in front. We could also look for their gravitational pull on visible stars in binary systems. If we find a massive, cold, invisible companion, it might be an ice star. Detecting one would mean ruling out black holes, brown dwarfs, and rogue planets. The discovery would be a triumph of finding darkness in a universe of light. The classic habitable zone, where liquid water exists on a planet's surface, doesn't apply to ice star systems. Every planet would be frozen solid regardless of distance. But tidal forces could generate enough internal heat to melt ice from below, creating subsurface oceans. Life here would be chemosynthetic, thriving on chemical energy, not sunlight. Ecosystems would be based on microbes feeding on chemicals from the planet's core. Larger, stranger creatures might evolve, using bioluminescence for communication or hunting in the dark. Intelligent life would face unique challenges: no fire, no sky, no stars to study. Their world would be water beneath ice, their technology shaped by pressure and chemistry. The culture and science of such beings would be utterly alien to us. The ice star's habitable zone is hidden, dark, and full of possibilities. The ice star is likely just a thought experiment, but it serves a vital purpose. It challenges our assumptions and stretches our imagination about what's possible in the universe. By imagining the opposite of a star, we better understand what makes real stars special. The cosmos is vast and strange, filled with objects we haven't yet imagined. The ice star reminds us that science advances by asking what if, and daring to explore the unknown. Whether real or not, its legacy is curiosity, a call to keep questioning and searching. The universe is full of surprises, and the ice star is a symbol of our endless quest to understand. For all we know, the cosmos may hold wonders stranger than any fiction. The ice star stands as a beacon, not of light, but of the thrill of the unknown.